Thanks for visiting the last talk at the Container Days. We're talking about distributed storage with Rook. Yeah, I'm Kim. I'm from Cloudibility. Cloudibility is a small, no, it's not so small, company in Berlin. We are focused on cloud and cloud-native stuff like Kubernetes, OpenShift, Ceph, Cloud Foundry, and other technologies. We are a consulting and architecture company. And
I'm Alexander. I'm a Rook core contributor. Yeah.
OK, today we're talking about Rook. Please, hands up. Somebody knows about Rook? Or, oh, OK. Yeah. Somebody's using Rook for production? OK. OK, this, just for information, this is a beginner talk. This is a high-level talk. We're talking about what is Rook, how looks the architecture, how can you integrate, or how is Rook integrated in the Kubernetes ecosystem, how can you use it, and we show a quick demo. Yes, how you can use the storage. In this case, we are focused on Ceph deployed by Rook. OK, what is Rook? Rook is an storage orchestrator. You are able to run storage solutions in your Kubernetes. The classical way, we all use storage with our Kubernetes. We use some historic storage. We have NetApp, we have Isilon, we have other stuff like OpenStack Cinder, but it's all, or Ceph, manual deployed, but it's all running outside of our cluster. We need a network connection to our storage, and this is not we think it's not a cloud-native way. We want containerized workloads. We want containerized storage. We think it's easy to handle. You have all your stuff in your Kubernetes, isolated, running, and all is controlled by your Kubernetes. We think it's great. Rook is an young project. We are a member since January this year in the Cloud Native Computing Foundation. Yep. And Rook is a framework to integrate storage solutions. Rook is not only a way to deploy Ceph. Rook is a storage with Ceph. It was the first storage backend.
Yes.
At the moment, we are supporting the last release, Minio,
It's in master,
DB.
to put it like that.
DB
is in master right now.
Okay.
Minio could have a chance to be merged this evening or maybe tomorrow. And NFS is also currently a pull request open. We are working on it. Yes.
So the storage backends are growing. If you are a storage vendor, if you have run your own fancy storage solution, you're able to use the Rook framework to use the standardized connection or the standardized integration in your Kubernetes. You can write your own you call it driver for Rook, and it's easy to implement your own solution via the Rook ecosystem in your Kubernetes.
Yeah. So I'm kind of showing here the architecture of Rook right now. Beginning with new objects in Kubernetes. Maybe you have heard about custom resource definitions already at Container Days. There were, I think, 2 presentations about it. Rook utilizes that for you to be able to create, for example, a Ceph cluster by creating a Ceph cluster object, where you specify your options and, for example, manage the pools that it should be created in Ceph by creating a pool object, or if you want an object store, you create an object store object. Through this part, through the objects, as already said, you can manage how Rook kind of deploys the thing. For example, as said with Ceph, Minio coming up, CockroachDB, and for example, the Rook agent is an important part here because it's actually doing the mount work for you. Well, for example, with Ceph, the mapping of the volume and then the actual mounting or more, formatting or putting it to for kubelet up to use. Rook operator, as it's there, it's operators. It's not like it's just a Rook operator in a whole. it's now a Rook Ceph operator, which is only doing the Ceph thing, and we have Rook CockroachDB operator, which just does the CockroachDB part. And the same goes on for MinIO to share the same code base, as he has said, with a framework, so that it's easier in the future to add new storage providers or more storage software. Yeah. So, let me switch slides. You kind of probably already know Kubernetes has some drivers included in its code, where, for example, CephFS and also Ceph RBD storage can be mounted, and NFS, for example. There's a range of drivers already in a core Kubernetes code. Though a big problem with that is it's in a core Kubernetes point. So if you want to add a new one, you would need to go through the whole Kubernetes flow of implementing a new driver in that regard. And it's not impossible, but it's not what Kubernetes wants to happen. What Kubernetes also with kind of their custom resource definition wants to happen is that you implemented kind of your own. And looking at Rook here, we enable the creation of custom drivers for software, and then also the mounting and stuff, the mapping, depending on what is needed, for your, own storage driver there. But with the simplicity of custom resource definitions and still using the Kubernetes natives, where we get into later on too.
Yes. This picture shows the logical architecture about our deployment. We see in the bottom line our Ceph parts. We see our OSDs on each of our Kubernetes nodes. We see our Ceph MDS services for CephFS. We have our Ceph monitors. We have our Ceph Rados gateway for object storage. The next layer shows the Rook architecture, or the Rook deployment. On each node, we have the Rook agent, which is used for configuring stuff on the node, formatting, or mounting mapping, volume mapping on the nodes, and we have the Rook operator. The Rook operator is the cluster brain about our Rook deployment. The Rook operator runs each configured task through our storage backend, creating some stuff in Ceph, creating Ceph, and in the upper layer we have our applications, and our applications don't know about the storage backend. They don't care about. The applications are using standardized Kubernetes stuff like config storage classes to access the storage in our backend. And this is what Rook provides for our solution, Ceph, MinIO, whatever.
Just to add here as a point, for example, if you're on AWS, you have like EBS, and if you're on Google Cloud, you have like a different, I don't know what it's called. But with Rook, you kind of have the possibility to have this abstract. So you have only you have your Ceph cluster on AWS and your Ceph cluster on Google Cloud, so that you kind of consume the same storage class on both clouds in the end.
Yes. Okay, how we can deploy Ceph cluster by using Rook. The left side shows the deployment manifest. Yes, it's not high enough. Shows the manifest to deploying a Ceph cluster by using Rook. We have our cluster kind. We're using the Ceph Rook.io API version, and we have some specs for our Rook cluster. We see the data host path. This data host path is the path on the Kubernetes nodes where all OSDs are mapped. The Ceph guys know this path like varlib, Ceph, OSD ID. The storage part is we can configure how our cluster is deployed. Do we use all our Kubernetes nodes to deploy the Ceph stuff, or should we use specific nodes? Would we use all devices collected in the nodes, or we can use device filter to specify, please only select, I don't know, def sd b till f for using as a OSD node, as an OSD device. And in the conf we have another many other options we can set. We can use specific storage configurations depending on our backend. We have the storage type BlueStore in the Ceph supports two different kein guter Platz. Supports the different storage types. We have FileStore, we have BlueStore. Since the Ceph Luminous release, difference is FileStore is used in XFS file system on each OSD. BlueStore is using no file system. All data is directly stored on the block device in the sectors.
Yeah. Okay. So to also kind of come back here to custom resource definitions. As you can see, it's not an API that is officially in Kubernetes, but we define it through a custom resource definition. And what comes out of this custom resource definition is kind of exactly what you see here. You have the Rook operator, the Ceph components that are getting spawned by just one object, to put it like that. You spawn one cluster object and you get, like, well, everything you need for the Ceph cluster done. Yeah.
Okay. We've deployed in cluster. Let's check how we can integrate it in our Kubernetes ecosystem and how we can use it. First, we're deploying a StorageClass for our backend. This is standard StorageClass manifest. We are using the Rook IO block provisioner for provisioning block storages used by Ceph. And we have our parameters to which pool we want to create in our Ceph backend, and what is our Ceph, what's our cluster name? It's named Rook in this example. And Rook is creating all the Ceph stuff which is needed to deploy Rados block devices. And after that we can use our StorageClass manifest to consume our storage. In this example, we are using a persistent volume claim, which is depending on the storage class name Rook block, and we request 20 gigabyte of storage, and what is the result? Rook's creating a 20 gigabyte Rados block device in our Ceph cluster, in our replication pool, which is defined in a storage class. We are able to create many storage classes in different pools to separate storage disks.
Yeah. Yeah. Now we're kind of coming to custom resource definitions finally again. As we already had there previously with the Ceph.io, Rook.io v1 API, it's not by default in Kubernetes. And with a custom resource definition, as said, we can define new APIs, new objects in the APIs we create there. CRDs just allow us to have the same experience as you have with existing objects, like with pods. If you run kubectl get pod, you get the same if you run kubectl get clusters. You get the same. You get to see the objects that exist there in the API there. And as with the normal objects like pods, you describe what should be, the desired state. And the same is for custom resource definitions. They can act the same way as existing objects. Yeah. And it's just easy through that to give the user the native Kubernetes native experience, but simply have, well, juggling around more YAML manifests or using Helm chart to template stuff. Yeah. Now, let me find a better side. We have the same manifest again here. Kim already explained most of the parts here. As we said, we can say the desired state like, yeah, use all nodes. So, for example, the operator will decide on if use all nodes is given, then spawn a daemon set instead of replica sets, or in the master right now, deployments for each OSD, each node with OSDs on it. Use all devices, what the selector for devices should be. Location is, for example, for Ceph specific, especially there with the crush map location, if I remember correctly right now. And store type, as you already said, the store type of the OSDs then. And for example, if you are, if you feel lucky, you can use host network mode on the components so that you don't have to go through the SDN. you can say what you want, your desired state, and Rook will, well, try its best to accomplish it. Yeah. Yeah. Now we're at the demo. Let me move that up.
A little bit tiny.
Bigger. Is it good in the back? So we have a repository. We have some files, for example. Yeah, let me just switch to screen. And I can see also what I'm doing. Yeah, well, not that screen. No. So, yeah, we have for the beginning block storage to show off there again. As what we just kind of showcased by showing them YAMLs. We have, for example, a very basic example by simply having a deployment of BusyBox and a persistent volume claim.
Yep.
And if we go into my key here. So we create a PVC, which is happening now. If we take a quick look at the PVC again, we are saying this storage class should be used. I want 20 gigabytes. It should be in this access mode. For more information on access mode, I suggest the Kubernetes documentation. They have a good explanation on the 3 different access modes there. Now that we have the PVC, we can see it's bound. This is the volume behind it. So if you would run a kubectl get PV. Oh, by the way, PV is the short name for persistent volumes, and PVC persistent volume claim. So we can see that. Again, this is the volume name, as we already seen here, 20 gigabytes. It's in read-write once mode. Reclaim policy is kind of what happens with the volume if it's released, so it's unbound from a claim. Delete in this example will just delete the whole persistent volume, meaning that Rook will delete the volume in Ceph also, so the data is lost in the end. We see from which claim it is again. And now if we just go ahead and create the deployment, we just have a very simple deployment for a BusyBox with termination grace period, because if you run sleep as a command, it doesn't really reacting to signals too nicely, at least in my tests, a bit like that. Yeah, we run a sleep, so we can exec into it. We have the volume mount where we say, yeah, mount this volume we specified to /data. And you, in the end, for the volumes, use this persistent volume claim, BusyBox PV claim. And again, if we look at the PVC, we see we named it like that. And now if we do kubectl, it's still creating. Yeah. And we see that when you do the scribe, it's already finished correctly, started correctly. We go into the pod. We're in a BusyBox. We don't have bash.
No bash.
So you see the lost and found folder there, kind of issue formats, like especially. I'm not sure if it's on XFS, but if you format the file system, you have in the root of the file system the lost and found directory. So we see that we have there the block storage. It was there provisioned. So if we go ahead and do, let's say this, let's just make it simpler. We see we have the file here, and if I go out now, run get pod again, and delete the pod. So we see the next one is creating. Let's just take a look. And we see that it's, again, started. And we can, again, exec into the pod, and we see there's still our file we just created. and it's still the same content as we had before. So block storage is working. Yeah, let me quickly take a look at the time. We still have time left.
It's the last talk.
Yeah. So an example I'll always like to give. So let me just, if my internet allows it. Perfect. So the kind of perfect example I like to use for Cephfs is I'm running a GitLab instance, and it's like, oh, we have like 1,000 new users, and we can just go ahead and scale it up. And I even got the right one. And we can just go like, yeah, scale it up to 5. And if we go into the namespace, and we see we have like 2 GitLab instances already running. The third one is just creating. And also there's some other stuff running in it. And we can see we can refresh, it's still working, even though we scale it up right now. Yeah. As it's taking some time, as you hopefully all use readiness and liveness probes on your application. For example, in the case of GitLab, depending on how good the machine is, it takes a minute or 2, in the worst case, to start up completely. So in the meantime, we'll go to the block storage again. And what is also a good example, what I'm here running. You may have already seen Elasticsearch in the name. We're going to create an Elasticsearch cluster on top of Rook on the block storage inside your Kubernetes cluster there. And those are the right manifests. Take some seconds. And it's in this namespace. And we can see the pods are starting. Some of them are panning because they're still probably waiting for all the PVs to be provisioned. No. Probably now, you know, the demo gods have just left us. I think the demo gods just left us here. So going back to GitLab, still taking some time to create, probably because of the image size. And if you just take a look, let's just hope to get the next instance up to see. Yeah, we see it's pulling the image. And we should hopefully see that the image is pulled soon. No. I think the demo gods left us here, really. Yeah, but even without that, without me scaling up the whole thing now, you see there are already 2 GitLab instances running. They're available under the same service. And if you look at the endpoint, you see there are for port 80, for example, there are 2 endpoints already for both instances. So both instances get served when we refresh the page here, which is hopefully, yeah, it's my internet is just too slow right now. Yeah.
You need a faster cluster.
It worked before us standing on a stage, so take my word for it.
Live.
Yeah. Yeah. So if you are like, oh, Rook looks cool, I want to play around with it, or yeah, you're running into some problems, maybe with configuration or something, we're sitting on a Rook.io Slack. We're happy to help. If you want to contribute, we have the repository on GitHub, and the documentation is on rook.io. We also have a mailing list on Twitter, and we also have a free second week community meetings. Yeah.
Okay. Some questions. Yes. So this, one moment. Technical issues. Yeah. Okay. Perfect.
So we currently mount Cinder volumes on OpenStack natively.
Yeah.
What use case would I have for using, we have no Ceph backend anyway, so we can use the object store directly. What use cases for using Rook would you say there are beyond doing that? What do I get by using Rook? Is that not the target audience?
I see the most use cases I see is by using bare metal Kubernetes clusters. You can use your direct attached storage in your nodes. This is what our customers are using Rook for bare metal cluster. You're able to use it on cloud infrastructures, but the block storage is directly provided by Cinder. And I don't see the need to use Rook on a Cinder block. Sorry. Yeah. Yeah.
There is, at least for CoreOS, especially because there's the Container Linux update operator, which kind of, well, is at least involved in the process of updating a node, which a user wrote. It's checking Ceph status before it kind of allows the reboot to happen. So it's, you know, they have like those before and after reboot annotations, and through that you kind of just spawn a pod on that node, which then runs a Ceph status. And if it's, well, health okay, then it's like, yeah, reboot. And if it's not health okay, it's waiting till it's health okay again before the node. So you could probably have some logic like that into, well, node removal there.
Oh.
Do you have any mechanisms in place to deal with dedicated network for storage? So normally you have like a separate Ceph cluster and a separated worker cluster. And the whole idea behind Rook is to combine these things, run a whole Kubernetes cluster over itself, so you need some dedicated network or need to deal with it.
Well, a few users are, I'm not sure if they're already doing it, but you can use, for a beginning, your host network with that, and then with custom Ceph configuration, tell every component to, well, use the other network for communication there. Well, if you join a Slack, I can probably send you into the right direction where we have a few users exactly using a setup like that.
Okay, cool.
Yeah.
Hi, excuse the question, but I'm from the ops side. So, what about custom crush maps for the Ceph layer?
Soll ich?
Yeah.
Okay. I'm also an ops guy. So you're running a real Ceph cluster inside of the Kubernetes. You're able to jump into this. You're able to change the config map also.
So I can just inject a new crush map if I ever needed that.
Yes, that's possible.
So it would also be possible to just add a standalone Ceph cluster, add this to the rest. If I just have the Ceph keys and the admin keys and everything assembled as I would for any other standalone Ceph cluster, for example.
I can take over.
Okay.
So that's one of the things I just tried out like 2 weeks ago. It's probably possible that you can just add OSDs, well, only the OSDs to the cluster. If you want, for example, an existing Ceph cluster to slowly migrate with the mons, especially there, I'm not. If you really want to migrate your existing data, you're running into problems because you can't really tell right now the monitors go like, they only talk to themselves kind of. So we said like only talk to yourself kind of, and even if you use host network mode, you would need to have a way to override the Rook IP addresses, the addresses we set there. It's definitely one of the things we have on a map, especially the John Spray from Red Hat. He's also looking into that exactly where he's kind of trying, he's implementing kind of a way to not start certain components if you, already have them. Like if you have your OSDs already, you can just not start OSDs in the cluster and only use the control plane in Kubernetes. Because it would make sense, depending on how you see it, like having 4 or 5 nodes for monitors and manager and stuff like that is not too important from latency-wise, but still something where if one is missing, you would definitely want it back ASAP and not having it lay around failed until an admin goes at it and fixes it, kind of.
Well, I add one on top. One final one.
No problem.
Sorry. If I got you guys correctly, it's I can administrate all my OSDs within Rook almost the same as I would be able to on a standalone Ceph installation with Luminous. So I can just remove failed OSDs, just swap out and do all the stuff. Yeah. Okay.
Yeah.
He says yes.
Yeah. Yes, you're right.
He knows.
It's it's still a bit of a manual process to add here, but it is possible. But you know, as we kind of one more page back.
Yeah. Okay. I will contact you guys and I will contribute.
And not only this, like the Rook here. The project on GitHub.
Okay. Other questions?
Do you have the balls to run it in production yet?
We have one customer is running it in production. Yeah, but it's a very small cluster.
Well, at least the Rook user survey revealed that a good amount of people are using it in production. If you're interested in the results of the survey, they are available somewhere on the Rook blog, and also Rook.io Twitter account tweeted about it some time ago. If not, join us, let us know that you want a link to the survey to check the results.
I'm already there, and thanks for being helpful. Yay.
Almost.
Is it possible to use Rook provided volumes from outside Kubernetes?
Yeah.
That's well, you can, especially, you have to see it more like that. If you run a Ceph cluster, especially for outside of Rook outside of Kubernetes workload, you would have to run with host network true. Because if you don't run with host network true, you have the SDN, which, is blocking the access kind of to the outside because of the different IP ranges they use. So, but if you use host network true, you can possibly, ignoring the fact that the mon IP is possibly changed because of failover when a mon fails, for example, as that, ignoring that, you could, probably use it as a normal Ceph cluster there. But as I said, with host network and some kind of script that updates the mon IPs depending on which mons are currently active and running in the Kubernetes cluster still. Yeah.
Okay, other questions? Okay, then, thanks.